So today we have JD Pirtle, and I'm super excited because I've known JD for a while, and we work together at ETL. So thank you, JD, for giving me this talk. And JD has been working in education, technology, and design for the last 15 years, and he's currently an educator at Ancona School in Chicago and founder of Depth and Light, an education, technology, and art and design research institute. So JD, take it away.
Thanks, Victor. Yeah, and thank you guys for having me. This is really a pleasure to talk to you. So I guess my talk title is a little provocative. I mean, I think that what I'm seeing happening right now in design and engineering in schools is both creating and solving problems. So unfortunately, we have a lot of creating problems, and I want to move to solving those problems. So that's really what my talk is about. I think, 10 years ago, or 7 or so years ago, I would have given a much more, I wouldn't say optimistic talk, but I would have talked more about all the solutions we have without talking too much about the problems. But now that I've been doing this for a while, I can kind of talk about both and hopefully offer solutions so we don't need more pessimism here. Let's see. Sorry, I'm in the wrong. Okay, there we go. So who am I? I'm a person that did not readily, I actually, after high school, I went to culinary school in Seattle. It was something that was like a compulsion, right? That I just wanted to learn to cook. I wanted to cook professionally. So I kind of fled Tennessee and went to culinary school in Seattle for 18 months and then cooked in French restaurants for about 6 years. My family all had like kind of a secret bet behind my back about how long I would last in this, just because of the hours, the low pay, the lack of insurance. It's just not really conducive to healthy living to be a line cook. I was working like 65 hours a week and just kind of burning the candle at both ends, as line cooks often do. So I kind of burned out with that, went back to school, had the intention at University of Washington in Seattle of majoring in music, reached out to the head of the music department. I don't really know who I thought I was, as some Yahoo that was hoping to go to an undergrad program, that I would just write the head of the department, who was like at the time, she is still a very well-regarded composer. What's even weirder is that she wrote back to me. All of you who are college professors are probably maybe half amazed by that. So she actually took the time to write me a really nice email. She asked me what kind of music I played. I told her I was in rock bands and I played some funk and played in a couple of noise bands and hip hop. And she was like, yeah, we don't do any of that here. She's like, we don't even have jazz. So at that point, I knew music was not a venue for me at University of Washington. And so she took even more time to kind of reach out to me and said, what else are you interested in? So I told her that I've been messing with like HTML and that I was really interested in animation. And generally, and I'd always been like really into computers. And I mean, I'm not one of these people like some people in our group here who started coding at like 10 years old or something like that. But I was interested in technology. I was interested in computers. I was interested in art. And so she pointed me toward this program called DX Arts. And it was pretty new at the time. Like at the point that I applied for DX Arts, there was only one class that was on track to graduate. So it was brand new. It was BFA and PhD. They didn't let you get a master's there. They wanted you to go away, get some experience, get a master's somewhere else, come back and do their PhD program. So what was unusual about this is that it was a fully funded by Apple, Intel, fully underwritten outside of the university. But it was a place where people were doing studio arts, meaning that you had to both do the research and make the thing. But it was very rigorous, separate from the art department. And later on, I would find out that there's a lot of acrimony between them and the art department. It's a 5-year pre-doctoral program. I did not go on to get a PhD. I went on to get an MFA. But the 5-year program was really designed to send people to a PhD if that was what they wanted to do. So basically it's a very competitive program. You start out with 200 people who want to get into the program, and then they whittle it down to 25. And then the next quarter, they whittle it down to 12. And then they end up accepting like 8 to 10 people. So it was like a really bad, kind of like a reality show. But at the end, we knew that some people were getting voted off the island and that some of the people we'd been with for these 3 quarters were not going to go into the program. So that year they actually ended up taking 8 people. So it was fairly stressful. I thought college was a place where you just declared your major and the department was glad to have you. It turns out that's not the case. There's some programs that are really competitive. So while I was there, I fell in love with stereoscopic animation and film. I actually shot the very first stereoscopic film with the new camera rig that we got, that the College of Art and Design got, and composited some Maya graphics that I made, and really just fell in love with like VR and stereoscopic animation and film. So I thought to myself, okay, I want to go somewhere. My wife and I were really ready to leave the Seattle area. I want to go somewhere and study VR. Well, it didn't take a lot of Google searching to find EVL. So I got into the School of Art at UIC, eventually wormed my way through a lot of annoying Dana Plepis to get a research associate or assistant position, and was lucky enough to join that group of amazing people. So, I mean, there's several EVLers in the audience, so they probably know what this is, the answer to this. So what do DX Arts and the EVL have in common? Both are groups of amazing nerds doing weird and cool stuff with art, design, and engineering. And what really drew me to EVL, and I think this is what draws, I mean, number one, EVL is just made up of a lot of really nice people, like really kind, welcoming, like harshly competitive people, just really nice people. So, but it was this kind of this interface between artist and technologist that kind of like took me back to like Billy Kluver and, you know, Robert Rauschenberg at like Bell Labs. So that was really what I was looking for, a place where artists and technologists could commune and make things together. And that really is what EVL was and is. And it certainly was for me. Let's see. So at EVL, I mean, you know, there's some EVLers on the call, so they obviously know this better than I do. But I mean, there's just so many interesting things here. And so finding my way around EVL as not as, I mean, like in a lot of places I went before EVL, I was the most technical person in the room. But then I went to EVL and I was automatically like one of the least technical people, or the least like technically proficient. So, you know, there are things that like I contributed to this project by attempting in some way to build a sound system for the Cave 2 VR environment. I actually put the carpeting in, which was one of my contributions, the carpet squares you see below the cave. So there's a lot of different ways to kind of get into a project without being a computer scientist, which is something I really appreciated. And the people at EVL really found ways for me to tap in or contribute, and it was really nice. Another shot of Cave 2. So this is a shot of like the Cybercommons classroom as it existed then. So it was just nice to be part of this, even though, again, I wasn't a computer scientist, but there were ways that people found my contribution to be valuable. Arthur, who's on the call, he and I collaborated with some students to make like this painting interface. So kind of doing things that were more art and design targeted for these, I mean, primarily technological projects. Here's some students painting on the wall, some little kids painting on the wall. And then I got a chance to make just things on my own. So like making like large Tenori-On instruments with processing and super colliders. So these were kind of some fun things that I could do as part of my job once I transitioned from a graduate student to a research associate. So I was able to be there for a couple of years as a visiting researcher. But, you know, it's a time period at UIC where funding was more scarce and my position there was not necessarily guaranteed year to year. So I really started to look around under the guidance of Jason Lee, who was the director at the time, kind of at what else I could do outside of the university system. And then I made the decision that a lot of people, not necessarily EVLers, the EVL folks were very encouraging of this, but some of the professors I knew thought I was losing my mind to leave the university system. But what ended up happening was I went to the elementary school where my children were attending. So they had been at Catherine Cook School since 2010. And in 2013, they created a position for me at Catherine Cook, Director of Innovation. Innovation had a much less negative connotation back then. And so what I was able to do, they created a new administrator level position. So I had the power to actually do some of the things they wanted me to do. But my primary mission was, we had just built a new wing and we had this gigantic 3,000 square foot old library space. So they wanted a maker space. The head of school and everybody had been to the D school. They'd been to Stanford. They had heard the term design thinking. They had no idea what it meant. And I'm pretty sure they still don't know what it means, but they had heard design thinking and they wanted to go to there. So my job was to create a curriculum for preschool through 8th grade and build and equip and run and maintain this maker space. So you can see here, if you look in the background, there's a place of where I took some painter's tape and I was envisioning this tile display wall a la EVL, which would be kind of like the centerpiece, not necessarily technology you need in elementary school, but the head of school was very interested in that, the kind of glitz and the draw to like prospective parents. So this is kind of the before picture. And after about a year of work, this is the lab as it was. This is, I think, my last day there in 2018. So just, I mean, a very rich space designed for 3-year-olds all the way to 14-year-olds. with, visualization, 3D printers. I'll kind of enumerate what's there. There's a tile display wall. These are MakerBots. They actually now are using Dremel machines. I installed 4 HTC Vives so kids could experience that. We did a lot of stuff with Google Cardboard. Here is the fabrication room. So pretty big laser cutter, probably one of the biggest ones in a non-manufacturing space at the time in Chicago. Full suite of like carpentry tools, hand tools, power tools, close-ups of some VR stuff. Kids watching the laser cutter. It turns out this was a little more exciting than television to them. Like they would just watch it for hours and hours. But really getting kids to understand how things work and how to be in charge of those machines. This is a very typical kind of mixed mode. There's several different classes in here. This is what it would look like in a typical recess. So these kids are actually electing not to go outside. They are spending their recess time sewing, making things, drawing. You can see a kid kind of actively bent over the self-healing mat there, making, I think, stuffed animals for that day. So the program that I started there was called IDEA, Innovation, Design, Engineering, and Art. And it was really meant to be like the synthesis of all those things. Here's my very Empire Strikes Back logo I made for it. And so it really covered these domains. These are the domains that I was interested in, that I thought were important for a school, that if we were going to do this maker thing, that we needed to go all in. So computer programming, robotics, textile arts, electronics, digital fabrication of all types, the more of the process of rapid prototyping, like the thought process and the doing of it. Wearables, we kind of dipped our toe in that, not very much. Carpentry very heavily, and some VR and a little bit of, with the school had already kind of been doing AR in a very like basic way with iPads. So we continued that. So just what was in that space. It was a pretty high-tech space and still remains to be, even for Chicago. But here's just some of the tools that were in there. Mostly I've already said this, I put 8 sewing machines in there and everybody thought I'd lost my mind. They thought it would only be emerging technology, but I felt it was really important to have traditional and emerging technology together side by side in the lab. And really the whole point, the mission, was to teach children when to choose which tool. Sometimes a paintbrush is the right tool for the job. Sometimes a laser cutter is the right tool for the job. Sometimes you want to go with Adobe Illustrator. Sometimes you need to write some code in processing. So they need to understand, not only have the experiences and the literacy to use these tools, but to understand not to throw technology at their problems. So that was really like important to me. And in a lot of ways, just, I'm no longer at Catherine Cook. My younger son's still there. He's about to graduate. But there's a lot of ways that this initiative really changed Catherine Cook forever. I mean, we did get national recognition, from some of the stuff we did there, mostly through the conference, the annual conference that we founded there. It also really changed. It's interesting. The faculty were the most resistant. The parents wanted it. The kids wanted it. The administration wanted it. The board wanted it. So the faculty were caught in like a pincer of everybody else's desire. And eventually, through what I often jokingly say, I was holding their hands and gently pulling them toward the lab. Eventually, through a lot of planning periods and a lot of understanding the way that teachers think and the way that they plan, we were able to do a lot of interdisciplinary, and even like the MIT, like the Media Lab says, like anti-disciplinary work together. We were able to add something to the strategic plan for the first time in 15 years, which was exciting. And they're still fulfilling some of those bullet points in that mission. So, I mean, a lot of people say this, like I hear this a lot from parents, especially, why are we putting this in the school day? We should be doing more of this, or they need to focus on this. And usually it's like core subjects, math, science, English, social studies, foreign languages sometimes. Those things are the things that most people think K through 12 kids should be doing. But then I think the biggest issue is you go to college, and if you have been exposed to engineering or design, if you have a parent that's a designer or an engineer, or an uncle or an aunt, or you grew up near any of that kind of industry, you might see that as a pathway for yourself. But a lot of kids don't see that because they are never exposed to it. So that's some of the questions I started. That whole idea started being very troubling to me. So I really wanted to see how we could fix that. I mean, this is like, I think, some of the obvious things, right? You got on the right, and this is kind of like a joking slide that I use. On the right, you've got a girl who is very much bent over, almost like it's like akin to riding like a motorcycle. She's not like kind of just sitting back like she's riding a horse. She's very much engaged in this process, versus like the kid on the left who is just a consumer of this of digital media. So like, it's really about that producer's mindset. You know, when I started saying this in 2013, it was fairly a new idea, but now you hear this all over the place. So luckily, I think as a society, we're digesting and then synthesizing this. This is my fun slide that I like to show to parents. It's like, you know, meant to be kind of like a joke, but also to kind of scare them into thinking about which side do they want their children to be. I really do believe that in some way, some segment of the population will receive instructions from a computer. And I think that even now we're seeing there's some segment of the population that is giving instructions to computers. And we're seeing, you know, that as technology, when technology is new, there's a privileged class of people, a priesthood, as it were, that is in charge of that and that knows all about that. And as technologies age, they become kind of, I guess, not privileged in society anymore. So where do we want our own children, like, you know, the children that we're either educating or that are our own children to be on this whole domain? So I'm just going to fly through some kind of this is just some of the samples and artifacts of work that 3-year-olds to 12th grade have done with me. So talking about computer programming, this is just kind of a soft, so normally when I'm working with kids, they use a graphical programming language till about 4th grade, something like Scratch, if you're familiar with that from the Lifelong Kindergarten group at MIT. And then in 5th grade, actually the end of 4th grade, but in earnest in 5th grade, we'll start shifting to a text-based language. In this case, it was Java through the processing platform. And so, you know, just starting to do computational drawings, nothing with functions, nothing very exciting, but it's just getting them thinking about writing code and what that code produces. So you can see just kind of all over the place. I say to them, you know, you have to write code. It has to be in this language, and it needs to produce some kind of design. And it's really interesting to see they put their own personality through these things. So this kid's obviously really into soccer. We've got a soccer pitch here. Could that be done in Adobe Illustrator more effectively and quicker? Sure. This is what he chose to draw, though. So you got, like, you know, cityscapes, things like that. This is my son's beaver with like a snaggle tooth and a patch over his eye. I'm not sure what's going on there. And then we start, you know, so that's like a 5th grade thing. So the next year in processing, they're starting to think about using for loops, about how looping can be the reason we might use processing over Adobe Illustrator. So and we also are starting to think about sending projects from something like processing to a format that can be read by the laser cutter and then etched. So these are little 5x5 tiles, and we're just continuing this notion of computational drawing. Here's some more details of these. These are obviously, this slide is definitely the higher end of the spectrum of, I mean, these kids now are in college programs. A lot of these kids are now in CS programs in college that were in 8th grade this year. Sometimes we're doing things that, like, this is a 1st grader's idea of what a narwhal looks like. And so they draw this on an iPad, and then we were able to process that in the laser cutter. Doing things like stained glass windows with acetate and cardstock. Sometimes History Fair comes along, and is it easier to cut out a Cubs logo, or is it easier to drop it into Illustrator and send it to the laser cutter? And so again, what's the right tool for the job? 3rd grade, big thing is the U.S. history, or the U.S. like, you know, kind of geography unit. So instead of the kind of worksheets and things they'd done before, I said, let's make a big 5x3 like map of the United States for each class. And what's really great is, like, this is cool. This is great. They loved watching the map. They liked the process of me taking the DXF and sending it to the laser cutter. But what is magical is when they take it to the art teacher and they embellish these pieces. And on the back of this, you can't see it, but they wrote their facts that they had learned about the states. And we've got 2 different 3rd grade classes and completely different ways that they took this project and ran with it. So I'm much more interested. This is okay. It's fun, especially if you've never seen a laser cutter before. But this is like where the magic really starts to happen, I think, of these projects. So thinking about digital fabrication. So thinking about working in like cheap materials and in low stakes, like the stakes are low because the materials are cheap and easily recyclable. It's fast to cut through cardboard. It's also easy to recycle it if it's not quite a masterpiece. So this is the 5th grade box project, Introduction to Adobe Illustrator, Introduction to Laser Cutting and Digital Fabrication. Also, they have to work on these boxes together. They have to collaborate, which it turns out is the hardest part of this project. There are often tiers. There's sometimes where kids stand up as if they're about to get into like a fist fight because they're advocating for their design, or they're just feeling the pressure of this project. And so this is 5th grade. They eventually fabricate wooden boxes out of these designs. And then thinking about like more actual, people say design thinking all the time, but like I'm really focused on design doing, because as we'll talk about later, schools have started to say words like innovation and phrases like design thinking, and they're completely empty of any action or substance. And it's something they're kind of checking off in their parent brochure, but it's not actually happening. So here we've got, I said to the kids, you know, I say limitation's the mother of creation, right? Of invention. So you have 4 limits. You have to make a chair. It has to be flat packed. It has to be done in Adobe Illustrator finally, and it has to be laser cut. So they start with these little models, and they go through a lot of ideas. They iterate very quickly. And then at each critique, we eliminate chairs. So teams get eliminated from the whole process, and the members get subsumed into other teams. So we go from kind of this size, then we scale it up a little bit, and they start to refine these chairs. Then we scale it up to quarter scale, and we start to work in a higher stakes material, right? This is Baltic birch. It's a more expensive material for kids to work in. And then eventually the kids start to actually fabricate full-size chairs. So that laser cutter was 180 watts, and it's pretty powerful, but it won't do 3/4 inch plywood. So what we did was we scored the design with the laser cutter and then had the kids use traditional tools to fabricate it. This is one of my favorite chairs. It's like a rocking chair, but it's like an homage to school. So it's got paintbrushes as the side and then pencils as the slats. They saw it as like a rocking lounge chair for around the pool, which was a wild idea. One of the reasons I like working with middle school age kids especially is that they have these completely out of the box ideas, and they're not afraid to say them out loud, and they're also not afraid to execute them. So here we've got the school chair. There's actually 2 ruler like armrests that went on there later. And it's fully functional chair. I told them that the chairs had to be not chairs of death. They had to actually be safe enough for the user to sit in them. Sometimes we do things like with community building. So like they did a lot of design on paper while I was on Adobe Illustrator on the tile display wall. And we would come up with something that represented each kid. So they chose like a cougar paw because that was the mascot of the school, or a pencil. We had letters for the teachers' names. And this was really just something that they took back to the classroom. They painted it and they hung it up on the wall. And it was just a community building thing. Looking at Frank Lloyd Wright, the Prairie School. This is like a project with humanities with the history class. And this is 5th and 6th grade laser cut windows. So you can see pre-finishing and staining and post-finishing and staining. So in 8th grade, starting to think about 3D printing. So introducing Rube Goldberg and some of those kind of more out there comics and the idea of producing this machine. So in this situation, the math students, kids in math, in 8th grade math, it was a collaboration between my class and math. They were given a crank and they were given a bell. And they had to design some kind of machine that would cause the crank, or the crank would start some kind of process, some kind of chain reaction that would eventually ring the bell, with the rule being that their hand could never touch the bell. So they had to find some way to ring this bell. So their kids are reading about a student who's like, or about a kid who's a synesthete, right? That when they read a book, they see these different words kind of appearing in the air around them. So the idea was to laser cut, or to design and then 3D print these words that this kid would see in this book, and to hang them in the classroom. And then, you know, sometimes it's just about, once kids have a few years of not only knowing how to 3D model, but also how to 3D print, and then once they've gotten to the point where they know how to maintain and troubleshoot the printers, I kind of turn them loose. I say, okay, for the first prototype, you get 10 grams. Second prototype, you get 15 grams. Final iteration of this, you get 25 grams. So instead of saying to the kids, okay, it can only be 6 by 6 by 6, I say to them, here's the mass, you figure out how you're going to use it. And so this is just some of their kind of, you know, when I turn them loose and I say it has to be 3D printed, this is how much filament you get to print, but it's just kind of the wild things that they produce. This kid really likes McLaren, so of course he had to do the McLaren ring that was out that year, if there's any car buffs in the audience. So what about little kids? So this is what a 4-year-old thinks the Willis Tower looks like. So this is actually done by a 4-year-old, so modeled on a app in an iPad. There is some support from their book buddies, which are the 4th graders, that would help them do this, but this is entirely done by a 4-year-old kid, and then we would send it over to the 3D printers as part of their Chicago architecture unit. This is like the interface when they would study snowflakes. So this is a 3-year-old's idea of what a snowflake looks like, teaching them to draw with their hand in this tool, Morphe, and then extrude it up, and then we 3D print it. Here's some of the their different snowflakes. In fourth grade, like the teacher created what she called a ferrarium. I did not come up with that term. They were studying gnomes and fairies, so using a really basic tool like Tinkercad to produce these gnomes and fairies, and then they took several aquariums and made the ferrarium where the gnomes and the fairies lived. Sometimes my students just blew my mind. Like this student, he did not write any code to do this. He actually just copied and pasted the same form and rotated and then rotated that. And I was just, this came out of the 3D printer and I was like, okay, that's better than anything I made in my undergrad program. So, and this kid's 14 years old. Now he's actually, I think, at MIT. And then, so rings, like fifth grade, like another limitation. You have to make a ring. It has to be 3D printed. We have to use Tinkercad to design it. And then just the variety of what they come up with is pretty wild in middle school. So this kid, Alexander, he's kind of at the highest level. I implemented a badging program, so digital badging, where students could earn up to 3 different badges in each domain in the lab. Once they were at the level 3 badge, that meant they could maintain the machines, they could unclog a MakerBot extruder, and if you've ever done that, it is not an easy task. And what that also meant was if you were having trouble and you were not a level 3 in 3D printing, you could go find a level 3 and get help from them. When there's like 80 kids in the lab and there's only a few teachers, having these level 3 badge earners to help other students is a huge thing. Here's his, like he really wanted some kind of speaker for his Android phone, and he actually designed this entire thing as a place for it to be charged. And there's like a little cavity here where that connects, that's like lines up with the speakers on the phone. And then he has like a fairly effective kind of crude speaker system here at the bottom of it. So in 2018, it kind of seemed like the program was going really well. I trained about 20 teachers. We'd started an annual conference that was going well. We had about 50 to 60 teachers that attended each summer. And I just started to get kind of bored. And I said, what if I went out into the world and consulted for other people? So I ended up consulting for like University of Chicago lab schools, North Shore Country Day, Lycée Français, about 9 different schools over a 2-year period in the Chicagoland area. And I learned a lot. And one of the things I learned is that I think that I've been going about this in some of the wrong ways. Some of what we did at Catherine Cook was really good and effective. Some of it only worked because of the conditions in that school. It only worked because of the timing. Usually initiatives in a K-12 school last about 5 years. And then people start to get bored and they look for the next shiny object. And I just happened to be at the zenith of interest in design thinking and the maker movement in schools. And so I went out into these other schools and I realized, hey, this is not working most places. And I mean, like, think about somewhere like the University of Chicago lab schools. They have 1 million square feet in that school. They have they're an independent school, but they're not actually independent. They have all of University of Chicago underwriting everything they do. And even at that school, I mean, they have 4 different beautiful maker spaces. There was still some trouble kickstarting. What is the spark that would make a program work? And that's really something that I started to think about, is if we have every single resource known to man, including all the tools, the know-how, the desire, and things are still not coming out of these spaces. Kids are still not understanding this or making things. So there's a lot of different things that I experienced there. So the problems with my model, going back to that slide, the problems with my model is that I mandated at Catherine Cook a separate class that was required for each kid from 3 years old to 14. That's not something that every school can do. And it actually wasn't something that Catherine Cook could do. It took time away from the rest of the day. And it actually put a target on my back for some of the other teachers, because they were like, if you take time for your class, this design and engineering class, that's less time I have for X, Y, or Z thing I have to teach the kids. So that was really not the right model, in my opinion, for teaching this stuff. And then there's some other things, right? So, I mean, a lot of schools have design and engineering in like after school camps. Those camps skew very heavily. The clubs and camps after school skew heavily, A, to kids who are affluent, and B, to boys. So we're missing the girls, right? The young women who might be interested in STEM or any engineering or anything like this. Like I said, I mean, K-12 schools, like I say, they're adrift in a sea of empty jargon. That's really true. I mean, I would say corporate America uses the word innovation heavily, and it rarely means anything. And I'm sure you guys have experienced that. And design thinking, like that is a term that people use, and very few people in K-12 schools, at least, are not actually doing any design doing. So they might do one design thinking activity per year, and they're like, check, they've got some kind of bingo in their head of program that they need to hit every year, and they'll hit it, and then that's it. But it's not actually really happening. There's no there, as people say. And the biggest thing is like incorporating effective and developmentally appropriate design and engineering into a K through 12 school. That involves interfering with the three biggest stress points in a school: time, space, and money. So this stuff is expensive. That lab that I showed you, that's $400,000. Most of which I had to, the person who hired me, the head of school, he didn't tell me there was no money for that program. He was very careful about what he added to the interview process and what he omitted. And what he omitted was there was no money for that. So I had to do a lot of fundraising and talk to big groups of parents when they were, at least 4 glasses of wine into the gala, so their pocketbooks would start to open up. But that's not really, not every school is capable of doing that. So the time issue I kind of talked about, I won't go into this too much, but I mean, if you take away from the school day, something's got to go. We got to rob Peter to pay Paul in this situation of time. Space, where is this going to happen? The biggest question now is like, do we want a centralized makerspace where kids go? Or should this be decentralized? Do we want to put some resources on carts? Or do we want to put a little bit of resources in each classroom? That's something that we're thinking about a lot in K through 12 schools right now. And money. I mean, again, this stuff costs money. And a lot of schools are like, okay, well, we can build this engineering program, but we have to end band. Or we can build this design program, but we're going to have to end the drama department. Nobody wants to be that person, right? And I mean, it's really a question of, can we have it all? And that's really what I'm trying to think about right now. And these things don't help, right? So when did vocational become pejorative? I know a lot of people at Lane Tech. At some point, Lane Tech was a place where people went and learned trades, and they made good livings in trades. They could afford to have a home and a car. Now, you could talk about how the United States has changed and the way that we are, the economics and the haves and the have-nots. But at some point, we decided that every kid has to go to college. And why aren't those building trades the right path for some people? And that's not really too much about designing or engineering, but I think us extruding every child through college, grad school, PhD is maybe not the best choice for every learner and every person. And, I'm not a math teacher, but I can tell you that the way we talk to children about math, the way we teach math, the way I was taught math is these things are important. Trust me, we're not going to apply them at all. We're going to learn them, we're going to test them, and then we're going to move on. Nobody said to me, it wasn't until my undergrad when I wanted to simulate a wave, and one of my teachers said, yeah, you should try processing. If somebody had said to me at 15, yeah, you need to learn trigonometry so you can simulate a wave that you can project on the wall, that might have like roped me in a little bit more. So solutions. I don't want to just come here tonight and offer a very bleak picture of design and engineering in K through 12 schools. And obviously I don't have all the answers here, but this is what I've observed after being pretty deep into this for almost 8 years. So this is what's happening right here. And if you have children in school, you have probably experienced this. And if you don't have children in school, I think this is fairly logical. There is an immense amount of linear pressure directly on these domains, these content areas. But hey, and I have them, they're imposed by parents, district, society, everyone, right? But out here on the edge, there are things like, so in K through 12, you'll see these content areas called the core subjects. And those of us who don't teach core subjects, that feels really great. But these primary core subjects are so important, so privileged. And the teachers who teach these domains, these content areas, are under so much pressure. But hey, out here, drama, fine arts, music, nobody cares about those. And I don't mean nobody cares like they're not important, but nobody's saying, hey, is the music teacher teaching to all the Illinois Department of Education standards? Nobody is looking at them. As long as the kids are making things, or learning to read music, or learning drama, or learning to paint, they don't really look too closely at what's going on. So what is my new approach to this? It is to start in the art room. So that sounds pretty weird. I mean, I think starting with like a real heavy design and engineering focus, why the art room? So the great thing about the art room is, number one, art teachers are already used to things not going well, right? If you ever, the first time you 3D print, the first time the extruder gets stuck, the first time the bed is not level, the first time, you leave the 3D printer and you come back and it's just a bunch of spaghetti of filament that's gone wrong. That is, to use a technical term, bums out a lot of teachers when they realize that. that it's not just going to come out perfectly. But art teachers are used to things exploding in the kiln if they didn't poke enough holes in it. A lot of teachers, especially older teachers, are not willing to say to their students, I don't know, I have no idea. Why don't we try it? Or let's experiment. And the art classroom is a place where there is already an expectation that there's going to be some nebulous gray area of creation, that there's going to be some discovery through process, and that process and product are both privileged, are both important. And again, like being free of this academic pressure of the so-called core subjects, that's huge. Art teachers are not worried about if kids are going to be able to take the art test to get into art school. I mean, that's not something that they're thinking about, but you have other teachers that have to do all of this test prep all the time. Especially if you have a child that's trying to get into selective enrollment schools in Chicago, the pressure is immense, and the percentage of students they take into those programs is tiny. I think somebody told me the academic centers in Chicago take a smaller amount of kids than Harvard or Yale do. And that's, we're talking about a kid that's going into 7th grade that is under that pressure. And I can't emphasize enough a place to say where it's okay for the teacher to say, I don't know. Because when you say, I don't know out loud, you can then go find out. If you don't say, I don't know to your students, I mean, they think that you came out of teacher school knowing everything that there is to know and that you're not a perpetual learner. And that's a terrible model for kids. So what do we need to do to make this successful? I think that the biggest thing is our teachers are not equipped for this. They have the right mindset, but it won't be too much of a leap to get them to start thinking like designers and engineers. We have to there's not really a lot of good curriculum that that focuses on the art room as a place where design and engineering kind of radiate out. And what I mean with this is that the art room is where people are building the literacies and the independence and the skills that they are then applying in other classes, in science, math, every other class. And then, professional development. There has to be training for the art teachers. I mean, eventually, like Bachelor of Science for teaching programs for pre-service teachers, Masters in Science or Masters of Education programs that actually prepare them to teach this way in the art room. And this does not exist. When I talk to people about this in K-12, they think I've lost my mind. So what did I do? I became a middle school art teacher. So earlier this year, I left the consultancy, kind of shifted it to a research initiative where me and a couple of other people who are K-12 educators are starting to look at this problem. And I am a middle school art teacher, and it gives me a chance to teach kids how to use technology and how to be creative with it, and how to apply things like digital fabrication, virtual reality. And we're doing painting, we're sketching. There's one thing that Jason Lee at EVL used to do was to make the Masters in Computer Science students who were in the game sequence, he used to make them get a sketchbook and some markers, and they thought that was weird. But he had them drawing their problems. And, we've been drawing for 50,000 years, 100,000 years, whatever it is. We've been writing code for a much smaller amount of human existence. And so these traditional tools like sketching are not incongruous here. They fit with coding and things like that. And the sketchbook is where I send my students when their code doesn't work. They go write some pseudocode. They sketch out their interface. And so these traditional and emerging tools can work harmoniously together. All right, so I just said a whole lot of words. So I guess we can move to like the Q&A part.